All right, welcome everyone to our first webinar where we are going to introduce to you Graph-based extensions, how to customize and enhance your GraphQL APIs. It's really good to see so many people joining us from several parts of the world. We're going to keep doing these webinars in the future. So this is our first one, so please bear with us. Today's session is going to take roughly 30 minutes. We're going to talk what graph-based extensions are. We're going to demo how to install and configure them, how to build them, and a little bit of a roadmap, future glimpse of what's coming. And towards the end, we're going to do a Q&A session. If you have questions, feel free to drop them in the chat, and we will get to them towards the end. So I think roughly 30 minutes or so, maybe more, and then we're done. So most of you, I hope, know what GraphQL is. I'm not going to talk about that, but I'm going to talk about what GraphQL Federation is and has been, and where it's going with the introduction of extensions. So GraphQL Federation is an architectural pattern that enables the creation of unified GraphQL APIs by combining multiple smaller GraphQL APIs called subgraphs. This allows you to move faster and to reduce the risk of conflicts. Grafbase is a platform for enterprises that promotes security and has unmatched query speed for those high performance scenarios. It's a drop-in replacement for Apollo, so it's very easy to take your existing setup, move it to Grafbase, and get the benefits of our platform. So GraphQL Federation, a lot of enterprises, large scale, are using it today, but it has some challenges. So one of them is that it requires what's called subgraphs, and a subgraph requires infrastructure, which takes time and costs money. You might have a scenario where you might want to get something up and running quickly, or you want to federate, let's say, a REST API database, or you might want to do pub/sub on Kafka or NATS. This currently requires a subgraph. We wanted to solve this for our customers, and this is why we introduced something called extensions. Apollo has a feature called REST connectors, which you might have heard of, that launched last year. It's a great feature, but it's limited to REST, and it's limited to the directives and functionality they provide. The extensions go beyond this by enabling you to build your own directives that can talk to, for example, databases, REST APIs, pub/sub, or even write your own custom auth logic, event streaming, or caching. So in the diagram here, you can see we have a gateway fronting a couple of subgraphs, and then we have two extensions called REST and NATS that talk directly from the gateway to the source. So that clients still have this unified interface, but you can quickly federate without the additional baggage and infrastructure of a subgraph in the middle. So the beauty of it is that you can mix and match depending on the use case. What are graph-based extensions? They're based on WebAssembly. So they're modules that you build with the graph-based Rust SDK, which gives you native performance. And as we said, there's no subgraph infrastructure needed, and it's secure thanks to sandboxing. And thanks to the SDK, it has a seamless integration to the graph-based gateway. Don't worry about N+1 queries, and it makes for really easy field level authorization, as an example. So some of the key features I'm particularly excited about is that you can now federate non-GraphQL APIs. You can federate databases, whether it's Postgres or Snowflake, totally possible. You can do event streaming with Kafka, NATS, etc. Or you can write, custom auth extensions that match your company's requirements. And each extension comes with fine-grained permissions. So you can say this extension has access to environment variables or not, as an example. So the benefits of extensions are, one, you can build your own extensions, right? You can now finally customize your GraphQL API without needing to fork and compile the router, or the limitations of Ray scripts, which don't allow you to do I/O. And you can do this with a really nice developer experience using our SDK. And you get this really nice feedback loop as a developer. You get an integration framework, you have the dev command, and you also can now, thanks to WebAssembly, do custom I/O. If you want to, you can publish it to the extensions marketplace that we launched today, or you can keep it in your own version control, depending on if it's proprietary or perhaps not useful to anyone else. There's also the possibility of using extensions that are already built by the community. Today, we have a handful of extensions that we launched today, such as the REST extension and NATS. But it's a growing ecosystem. We have a lot of partners and customers already building on this, and we're really excited to see what people will build. So now we're going to do our first demo of this webinar. Tom is going to talk about how to install and configure extensions.
Yeah, thanks, Frederick. So quick introduction, I'm Tom. I'm a Rust developer at Grafbase. And I'm going to talk about how you would use one of the extensions we have on the marketplace. On the one hand, very nice feature of extensions is that you can build your own, and Ulysses is going to show you how to do that. But on the other hand, we think there's a lot of use cases and like protocols and talking to specific systems or specific APIs that are going to be reused across many enterprises, many deployments. And so it makes sense to have them, to have a shared high quality implementation. So I'm going to show you how you would take one of the extensions from the marketplace and use it in a toy project. I'm going to share screen. Okay. Can you see my screen?
Yep.
Yep.
Yes, very good. So I'm on the Grafbase website. I'm going to look for extensions, and we're going to pick two of these for this example, the REST and the NATS extension. The UI and the general experience is going to be reminiscent of trace.io or NPM. If you're familiar with that, you're not going to be very in very foreign territory with the Grafbase extension marketplace. So each extension has a README, like you have licensing, ownership, and so on, like different versions. And we've documented already the ones that exist a little bit, and you can see it's mostly about adding the extension to your gateway configuration and setting it up. And setup can take two shapes, basically. It's going to be directives in your GraphQL schemas that can be in your existing subgraphs, or virtual subgraphs, which are schemas that you publish, but that don't match a URL of a subgraph that can be called. So that's for subgraphs that are completely resolved by extensions. And that's what I'm going to show you right now, but that's just one possibility. You can have extensions for resolvers, for authentication, for authorization in specific subgraphs, and as part of your existing subgraph schemas, just by adding directives. We're going to come back to all this, so I'm not going to dwell on the README. Just to mention the NATS extension, this part. So you add the extension to your configuration, but to your gateway configuration. But every extension can also take arbitrary configuration, typically for connection strings or things like that. So let's jump into it right now. I'm going to add so I have an empty project. You can ignore the files that are here. I'm going to talk about them one by one, but I'm going to start a new graph-based.toml that would be your gateway configuration. So you would add that to your gateway configuration, or like here, you can start from scratch. So I copy pasted that from the registry. I'm going to use the REST extension with the latest version. And I'm going to, just to demonstrate that you can put more. So that's an alternative syntax for the same thing. So 0.3.3, yes. And I'm also already going to add the configuration for the NATS server that I have running locally. Okay, So it's localhost. That looks good. Before I start the server, we have to look at the GraphQL schema that I'm going to use. It's a virtual subgraph, meaning there's no service running anywhere. It's just purely based on extensions. So let's go through the schema progressively. We have it's an Apollo Federation v2 schema. So everything that's and love from Federation is accessible. You can work with entities. You can have @shareable, @override, and so on. And then we use @link to import the definitions of specific extensions from the Grafbase Extensions registry. So here we import the REST extension. Let's do 0.3. That will also work, but let's keep things in sync. So we import 2 directives from there. Let's jump already to REST endpoint. That's one of these 2 directives, and that tells us, okay, we name that endpoint REST countries, and the base URL, it's that demo REST API that's public and that sometimes doesn't work. We'll see if we get into errors when we create this evening, but that's a public REST API that's external. So let's see. Yeah, let's finish with the REST extension maybe, just to show. So we define this endpoint here with the URL, and then we have two fields on the root query type. They could be anywhere in the graph, but I've defined them there. We use that endpoint we just defined, and then the parameters you would expect: method, path, and selection. You wouldn't expect it, but it's a very powerful mechanism where you can use JQ syntax to basically process the response from the REST API and make it fit into the GraphQL types you want to define. So to explain this one, for example, all countries is going to return an array, and for each element in the array, we take the name.official. Name is an object with different names, and map it to name. The region, we map it to region, and TLDs is mapped from the TLD property. And same thing here, that also returns an array. We take the first element, it's a country by name, and we return the same fields. What you'll notice in the path is a pattern that we have developed for extensions where you have many kinds of templates that can take data from many parts of the query or of the environment, where here we take from the from the arguments to the field, the name. We could take everything. There's a bunch more rules. We could take, so in different, based on the scalar type of the definition of the extension, we would be able to take from other fields on the same object and so on. So it's a powerful mechanism, and we're going to see that a bit more with the NATS extension. Yeah, I think that's what I wanted to show on the REST extension. On the NATS extension, same thing. We import the extension from the registry. We have 2 directives, NATS publish and NATS subscription. And then we have a mutation field that publishes on the NATS. So if you're not familiar with NATS, it's an event queue basically. So we publish events to topics or subjects. We can then listen to them in other parts of the system. So we have kind of modeling a bookstore where books get sold, and this gets sold by ISBN and price. So based on that input, we are going to publish to the book sales topic and select everything. And then we have the other side of the subscription, where you have a subscription field. That's the book sales. And there we could, we hard-coded the subject here, so we could hard-code it as well, but I wanted to demonstrate you can pass it an argument and have the flexibility to use that. Display a bit of the flexibility of that selection language. We also have the selections here, and you can use that to map the types of the events to the types of the GraphQL types you want. But here we're using it for filtering, for example. So we're only interested in these events if the price is more than 10. So I've described my my schema. I think that was the hardest part of the demo. Now let's see how it works when we start using the extensions and actually running queries. So the first thing you're going to have to do is install the extensions. And for that, we have Grafbase Extension install command. And you're going to see two things: a Grafbase Extensions directory that's like node modules, if you wish, with each extension is just manifest.json, that's metadata, and the extension.wasm. And we have a log file for reproducibility. Good. So now we should be able to start the federated graph. So we are going to go graph-base dev, gateway config is graph-base.toml, and graph overrides. So graph overrides here is just because of its dev. I haven't published that to the schema registry, and there's no subgraph running. So we're just telling graph-base dev. The schema is the one I just showed you. We're going to start that. Very well. So it's running on localhost 5000. Good. So let's query these fields. So we had the list all countries field that queries from that REST API, that external REST API. I've seen 500s when extension error. Yes. Okay, so it's the API that sometimes responds with errors. Sending requests. Did I forget something in the configuration? Don't think so. It's the joy of demos.
Looks like the API is just super slow today. We have similar things.
It might be a timeout.
Yep.
Let me see if I can return a single country. Okay, it looks like the API isn't responding. Okay, I can show NATs. Or we could try to get to a different API. But
no, let's go with nuts. It was today like 5 seconds for this API already.
We can try maybe later. So we had that cellbook mutation where we can send events and ISBN. I'm going to make one up, sorry. And price 20, and that returns a Boolean. So returns true, it's not very interesting. So I don't want you to take my word for it that it's working. So I'm going to subscribe to that field. And for that, we are going to use server sent events with curl because there's no support for subscriptions in the Explorer yet. Okay, so you see query subscription and then save that says endpoint. I just defining the schema. Okay, yeah, and you see the event came through, and we have that filter, if you remember, that any price under 10 is not going to show up, so 8 won't show up, but 80 will show up. So that's working. Let's go back here. Yeah, okay, the API is back up.
Now it seems to work, yeah.
Yeah. Okay, should have picked a better public example or run something locally. So name, region, TLDs. That's a big list, so sometimes it takes yeah, now it's back up. Great. You see we mapped everything. Response there, and like country by name, Poland. Yeah, 500. Great. Okay, let's forget about the API. But you remember the name? It worked once. That was yeah, that name gets mapped to a path argument, but could also be mapped to a query argument. So if you had a name equals, for example, like that, it's very, very flexible. I think that's everything I wanted to show. Maybe it's time to pass the screen on to Julius, who's going to show you how you would build an extension, not just use one from the marketplace.
Yeah, cool. I'm Julius. I'm also a Rust engineer. I've been in Grafbase for a few years now, and I'm going to show you quickly how we're building them. Like, first and foremost, we built the SDK for ourselves because we need to build a lot of extensions in the upcoming future. and we want it to be as nice as possible. So that's why I'm happy to show you what we came up with, because after building 3 extensions, this feels kind of nice. So I can now show you how it looks like in the editor if you give me the screen share, Frederick. So I'll share my screen here. This is visible for everybody.
Yes.
Yep.
Okay. So first I'm going to start, like, this is a scaffold project I created. You create these with Grafbase CLI. So you can do Grafbase extension init. You give it a type. There's now 3 types, different points where and different ways we call the extension. This one is a resolver extension. So we set the type to resolver and the name is echo. So this is how the project was created originally. And what the scaffolding does is that we have first the extension TOML file. This is the main info point. So you define the name or ID over here, the version, the kind is here too, it's autofilled from the CLI, and description, license, and so forth. And here you define the default permissions for the extension. So this is what if in your configuration, if you do something like, or if the user does something like this, so extensions and rest or echo equals 4.1, then the default permissions are used. And this is what the extension developer announces, like, I need these permissions from you. You can, of course, override these. So you can say extensions echo, and this one is then the version. And then you can say here, like, std out equals true. And now the user overrides whatever the developer wants to do. But yes, this is how these work. And then the third one over here is the directives. So directives is they define that you have the definitions what the extension provides. So typically, then it's like for authentication, you probably don't want to define any directives, but for resolvers, it's usually a good idea to define at least some directives that the user can use from your extension. And this here defines which file contains these, and I can take a look over here then. So this is a simple extension. So first we import a few types from the Grafbase engine. We have an input value set. So this thing is a type that takes arguments from the field's arguments. So we define here that take every single arguments the user types to the field where they use the directive, and they are then provided to the extension to be used. That's the echo field directive. So this is the first one. The second one is a random bank event. So it's like a subscription kind of thing. And here we define the selection. And selection is what Tom showed. Like you can do, you can map the data somehow. Like, okay, I'm only interested on these fields, so I want to filter it with something. And we use JSON template here. So it's kind of a string, but you can take arguments. So as Tom showed, you can use the args.something syntax over here, and then you can do powerful things such as filter only. Like you have an input of I only interested of money value above 1,000, and you can build queries with the JSON template. It's kind of powerful thing. The third thing I wanted to show now is the librs. This is also generated for you when you initialize your new extension. An extension development starts by defining the root type, the extension itself. And here it's called echo. It's a struct, where it can be enum, it can be any Rust type. And the important part here is the proc macro above. So we define that, okay, this is a resolver extension. You can also do authentication extension over here, and that changes things, what traits you need to implement. So your editor will nag to you to define all of the things correctly to get this working. But we go with the resolver. Then inside here, what we store is JQ. This is coming from the SDK. This is tooling. To make it simpler for you, that I have this JQ input and I have this JSON coming in, and this one then compiles your JQ filter and then caches it for for the further requests that come in. So basically what this does is that selection data come in, and then a list of data comes out. So a filter can, of course, multiply the data. So that's that possibility we take into account over here. Right. So then when we define the struct to be a resolver extension, it expects us to implement two traits. The first one is the extension trait. This is only the initializer construction. So that gets two different things. First one is a schema directive. We don't have any defined in this extension, as you remember seeing in the definitions over here. We only have field directives, no schema directives. But what Tom demonstrated with the REST, there was the REST endpoint, and that's a schema directive. So all of them, they come here, and you can then access them through the schema directive structure over here and deserialize them as you want. And then the configuration, this is again what Tom showed. This is from the Grafbase TOML. So you can have custom configuration mapping over there. It comes serialized over here, and then you can deserialize it into a structure and configure your extension. The other trait you need to implement for a resolver is the resolver trait. So it has two important methods. One of them is the resolve field. You get access to the subgraph headers. So the subgraph this extension is in, the headers that are filtered into configuration, or where the rules, header rules, are mapped to that subgraph, you get all of them, the headers over here. Name of the subgraph, the field directive, and this one is important for us. The field directive over here contains whatever the user passed to the echo field in this case. So we can see this in, I have already a subgraph over here. So you see over here that we have the echo, and it has the echo field directive over here. We didn't use the input, but it has a default value of star. So we have that available even without writing anything over here. So we get the default value to the directive in the call. And then there's field inputs. We're not going to use them yet. They're going to be more useful in the future. So what we do over here, we call from the directive, we can call the arguments, and the arguments come as serialized data, but we need to define like what does our directive look like. And here we have the input, and this is the input from the directive. And then we expect, or we want to read one argument, what we're calling, and we want to read the input, and we take whatever JSON comes in from there. So we do that, we save the directive, we create a new output, and we just echo back the input to the user. So you can build this extension by running Grafbase extension build. This compiles the extension and creates them all the important files to the build directory. You can see them over here. Let's see how they look like with some better syntax. So this is the WASM module. We usually have below 2 megabytes. There are some hundreds of kilobytes typically, and then the manifest. And these two files are important for you to when you want to test the extension. There are a few ways of testing this. One of them is running the Grafbase def command. So I have the Grafbase TOML file, and I have the overrides.toml file. Let's see quickly what's in those. So Grafbase TOML, I enable introspection, and then I define that we have an extensions echo and the path. So we can define an arbitrary path where these two files have to be. And that's how we can test that. And then we have the overrides TOML again, because we don't publish anything. So we define that we have a subgraph called echo, and the schema is the subgraph.graphql. So now we can start this. As you can see, it's running, and then we can curl use the echo. So we have echo, and there's the input, and foo, and it responds back foo. We can change something else like test over here, and it responds back test. Then there's the other one, the other function or method in the trait is called resolve subscription. This one gets the headers, the subgraph name, and again the directive. And this is a bit different. It's a bank directive, so we have the selection over here. So this is the filter we want to use. to filter our values. But here it's a bit different, so we need to create a new type. So we create a type, a structure called random bank events. We have the JQ inside. We have a random generator, and then the selection from the directive. And then we implement the trait called subscription for it. So this is the thing that kind of makes the subscription tick. So every time we kind of pull this in the engine, and these can generate new values as long as the value is something else than none. What we do over here is just wait for half a second, generate a random amount from 1 to 2000, random credit and debit, and then serialize the value, run it through the filter over here. So we use the selection, and then define the output and return this output for the user. We have ways to test this too. Like there's another way, like easier way. What I like testing more is to use the integration tests. So we generate this also to stop automatically for you, and the SDK has all the toolings to test your extensions. So here we can define the subgraph. We can also build a dynamic schema out of it. It either can have a virtual subgraphs, or it can actually have a real subgraph. So there are methods also to generate existing subgraphs with a port and a server. So if you want to test things like authentication, they're quite useful. And then there's a test config, so you can define all of the permissions and everything through this. And test runner, which will compile your extension and start a real Grafbase gateway in the other thread. Now we run a GraphQL query against it, and then we get a result back, and we assert that. The same with the subscription. So we have test functionality for that too. What is different over here is that we send a subscription. We have some type definitions for the data we get back, and we call the GraphQL subscription, which creates us a stream of events coming from the gateway through the extension. We want to take three events back out from there. We expect that we get 3, and then we expect that because in the subgraph file over here, we have bank events of minimum amount of something, and then we select amounts that are larger than the minimum amount over here. So this is the filter of the JQ. And let me see the test again over here. So yes, my subscription over here was minimum amount of 1,000. And then we are expecting that every single thing should have amount larger than 1,000. And we test it one more time just to be sure that we can repeat the subscription in our extension. Okay, now we can run these easily with cargo test. It compiles your extension. It compiles the tests, and now it runs them over a real Grafbase gateway. And the subscriptions take a bit because it waits for enough events to come out, but they will then test okay. And this is kind of the way how we develop the extensions, and found it like we can do pretty fast and do new extensions pretty fast with this kind of SDK and this kind of approach. The last thing I wanted to show you is that there is the SDK. This one is published to crates.io, and of course, being Rust, everything published to crates.io will have their documentation generated automatically to the docs.io. So no, docs.rs. So for example, we have already host modules over here. So we give you like tooling to access NATS and Kafka and you know, all the services to make it as easy as possible. We define all of the test configuration over here, test tooling over here, and then we have lots of helper types to help you out to use your extension and use the directives that are defined in the schema. That's all, I guess, what I have.
Sounds good. All right. Thank you, Tom and Julius, for demoing how to install, configure, as well as build an extension. And as you can see, using an existing extension from a marketplace is extremely easy. So the goal of extensions is really to make your time to market to federate any kind of data source or plugin auth really, really low. We want to make sure it doesn't take you weeks to stand up, a federated graph. Perhaps if you want to, convince someone in leadership or perhaps you just want to federate something to reduce time in your current sprint, right? I mean, that's the goal. And when they're not available, building your own should be a really nice experience. That's what we're aiming for with the Grafbase SDK and the Grafbase CLI. And as Julia said, if you want to read more about how to build and install extensions, you can go to grafbase.com/docs/features/extensions. So we obviously launched extensions today. We have a lot of improvements to the SDK and the gateway itself, of course, continuously based on feedback and some of the things we have in our backlog. But we're really excited about some of the extensions that are coming in the coming weeks and months, particularly around authentication and authorization. We've heard loud and clear that there's no one size fits all, especially for larger enterprises. You will likely write your own auth extension that fits your requirements. But we're also going to launch a few ones that are perhaps a blueprint or a template that you can look at, and then you can fork it and tailor it to your needs. But we're also launching generic ones like Kafka S2. All the founders on the call, which is great. Redis, as well as databases, Mongo, etc., that are coming. But if there's something here you would like to see, you can contribute it by opening a pull request in a repository in GitHub. Once it's merged, it'll get published to the marketplace on grafbase.com/extensions. All right, let's move into Q&A.
Okay, great. We have a number of questions that have been asked. And as we go along, if you want to contribute a question you haven't been able to yet, feel free to either use the Q&A button or to write something in the chat to us. Our first question comes from the Q&A, and someone anonymously said, and I know Tommy already answered it in the chat, but just in case someone else has the same question and hasn't seen that yet, when we specify a link to the extension in a GraphQL file, does it have to be a graph-based link? i.e., can we write private extensions?
Yeah, I can take that one maybe. So the answer is it's completely optional. Like it can be any URL. There's a requirement that it points to a manifest.json so that you have built an extension there, but it can be a URL to a different place, your own registry. We can make that. It can be self-hosted as part of the enterprise platform, or it can be a file URL and point to a local path on your own computer with an extension you built locally. So that's for convenience, we have the public marketplace, but it's completely optional.
Okay, great. And the next question that we had that came in is, how do extensions interact with existing subgraphs if I already have a federated architecture?
I will take that one. It depends on the nature of the extension. You can add authorization extension, but typically on any existing subgraph, it's just adding a directive and importing those on the SDL. For resolver extension, it's a bit different. Today we don't support mixing actual GraphQL subgraph and resolvers because they have really different resolution behavior, but outside that context, they can be mixed. And within a subgraph, multiple extension, for example, one REST extension, NAT extension, as we saw in the demo, can be mixed together.
And the next question that came in is, how do extensions compare to subgraphs in terms of latency and request handling?
I can take that one. So the WASM jump between the engine and the WASM module, there's some tens microseconds of latency in that typically, but usually it's not noticeable at all. We've been testing this up quite a lot. We've been using WASM for ages in Grafbase and started with the hooks earlier. And there are certain things I noticed that can be still slow, like certain encryption algorithms. But for this reason, we have certain things that we know that are still not fast enough. We do those in host, and they're available through the WASM bridge, so you can use them through the SDK. But the things that need to be fast are run in the host in the native code. But in general, like typical things, what you want to do with NATs or REST or whatever authentication, it should be super fast. A tiny bit slower than running a native function, but still not too much. Some microseconds.
And to add for context, the additional cost is crossing that WASM boundary, but within WASM, we see native speed, basically. So.
Okay, great. And our next question is, how does Grafbase prevent conflicts if multiple extensions interact with the same data source?
There's when there are multiple extensions on a data source, today we will treat them as possibilities. So if a field, for example, has multiple extension that can provide it, or an entity or something like this, we'll treat each of them of possibilities. And then it's an aspect of query planning to know, okay, which one is the least costly today to do it. In the same way that if multiple subgraphs can provide a set field, we'll try to use the one that is the least costly to use because it has no requirement or little ones or ones we already have in the query, things like that. And otherwise, it's the handling of conflict is done by the composition aspect, same as traditional federation.
Okay, and right now there are only 2 more questions that we have left that are unanswered. So if you have any questions and you're listening to this, please feel free to put them in now so that we can answer them while the team is all here together. What is the approval process like to contribute an extension to the public marketplace?
I can take that one. The right one, right now we're thinking of, because right now all of the extensions are still in the Grafbase repository because we're just, implementing it and it's handy to have them nearby. But we will do a subscription, we do extensions repository where merging things there, we'll publish them to the extension marketplace. And then we have all of the pull requests. You do a pull request for us. We review the code and see that it's kosher, everything is fine with that. And when we merge that, and then it gets published to the extension marketplace. We don't have that yet, but next week we start with that. Eventually, we will do something more. We will probably allow publishing them directly. But right now, it's still blocked for us because we're just releasing it and seeing how it works out.
We just got another question anonymously through Q&A, and we had mentioned like the N+1 problem being handled. Can we talk about that a little bit more?
I will take that one. So we do quite a lot of work to basically integrate with the extension really within the engine. And so when we mention the N+1 problem is that extension don't resolve a single field, they resolve a batch of field each time. So and by batch, it's not only when the field, for example, so if a field is present multiple times in the query, the extension will be called only once with each of those instances. And if it's within the list, we will return, we'll expect an output for each of those items. So it's really, there's no N+1 problem because everything is inherently batched already. And in the same way for authorization, which we didn't talk today, but we also integrate quite deeply within the engine. So meaning that we really do fit level authorization in the same way, meaning that if there's some authorization for a field, we will call the extension only once for all the fields that needs authorization. So avoiding the traditional problem from GraphQL where each field is treated individually, separately. Here, everything is batched all the time.
Okay. If that doesn't answer your question to the person who asked that, please feel free to follow up and we can discuss more. But the last question that we have for now is, are there any restrictions on third-party API authentication like OAuth API keys when you're using extensions?
No, I was actually planning to do a demonstration of OAuth extension, but no, we should be like, I just want to do an example and see that we can do all of them, and then make the SDK so that you can implement those auth extensions. I was thinking of trying out a GitHub like next week and see how it looks like, and we will of course do a blog post of it and show you how it's done. But yeah, the idea is that there's no restrictions, and if there is, it's a bug report, so we will fix it.
And to expand a bit, like our only restriction is the current limitation of WASM, being that the IO, it's not entirely there yet. So that's why you do HTTP request on the host side and you expose an API and as SDK. But today you can do any HTTP request within the WASM. We support NATS, we will support Kafka, we'll support different things. And when WASM catch up, you will basically be able to do really anything.
Yeah, I want to expand that a bit. So right now we're in the WASM WebAssembly system interface. We're in the preview 2 phase, which gave us the interface is how we can pass strings and things like that easily between the host and the guest. I've been following and I've been playing and implementing things in Tokio and Mio. These things are not ready yet, so doing I/O in the guest, async I/O, for example, you can do sync I/O already. Async I/O in the guest is not super nice yet. The WASI preview 3 is coming this quarter or next quarter, but in the beginning of 2025, this will add async support. So you can use the host runtime to run the guest futures. And right now we will provide everything in the host side, so the functionality is there. And when the WASI P3 is up and running and working, we will upgrade, and then we will enable more features from the WASI side.
Okay, and we have another question that's come in through the Q&A, and that is, do you have plans to review extensions, for example, if they have some malicious code?
Yeah, I think that's kind of my idea, at least, thinking of like first starting with the repository and pull requests and then reviewing every single thing that comes in. And those are the ones that are in the public marketplace, so-called blessed extensions. So we're gonna start with that. Yes.
Yeah, there's definitely that angle for sure. I'd also add with WebAssembly, like you can forbid network access, forbid access to environment variables, like you can control I/O. Of course, like if you have a malicious extension, that can still damage. So these will be reviewed and blessed, but you can, like you have multiple layers of defense.
And I know some of our customers will definitely need to read all of the source code of their extensions. So everything has to be open source and has to be available for them to read.
Okay, fantastic. We've reached the end of Q&A, I think, unless anyone has any questions they want to trickle in while we still have a couple of minutes. I think, Frederick, you can move on to our next section.
Yeah, thanks for those were some great questions. And the good news is extensions are available today. You can try them by going to grafbase.com, signing up for a free trial. If you want to talk to us, you can book a demo on the homepage. You can also chat with us in Discord, or you can file an issue on GitHub, subscribe to X or LinkedIn for updates. And as I mentioned before, the docs are also available on grafbase.com/docs features extensions. That's it for today. Thanks to everyone who attended, and looking forward to connecting with you in the future.